I'm Johnny Winn, host of the Elixir Fountain and senior software developer at Weedmaps. And I have a confession. All our applications inevitably become big balls of mud. We can lie to ourselves and say they won't, but the truth is, everybody's seen it, right? We've all kind of encountered those code bases where we're like, this is my favorite. Oh, our code is a little off. Can you take a look at it? Or as you're job interviewing, how many people have had that interview where they're like, yeah, we're still working on things, and then you get to it and it's this big ball of mud? Nobody? Okay, come on. So, but the thing is I'm here to say, if we embrace that, if we say, yes, we're going to encounter big balls of mud, then we can actually design our applications in a way that we can prepare for the future without overcommitting to the present. Today, we're going to cover some techniques and how to manipulate those balls of mud so that there's not one big ball of mud, but several smaller balls of mud that become easier to manage, easier to change, adjust that code, and handle future changes, and really the power to delete that code. If you're familiar with the concept of big ball of mud, there was actually a paper written called, guess what? Big ball of mud. Brian and Joseph, here's a little excerpt from it. A big ball of mud is a haphazardly structured, sprawling, sloppy, duct-taped, and bailing wire of spaghetti code. How many people have seen code bases like that? How many people are part owners in code bases like that? Yeah. It's inevitable, right? We don't mean to. Nobody wakes up in the morning and says, you know what? I'm going to write some sloppy spaghetti code, right? But it happens. Because as John Lennon said, life is what happens to you while you're busy making other plans. But you remember that first commit, don't you? That first commit's pure. It's nice. We usually use messages like initial commit. This is not a good idea. Why is this not a good idea? Because this is your one opportunity to embrace the beauty of that pure commit. I like to use things like, this is not a dress rehearsal. This is your life. Evolution is all about looking forward. These are actual initial commits that I have, by the way. And this one's my favorite, make it so. But that first commit, it's very short-lived, isn't it? Doesn't last very long. Because you know what happens after the first commit, right? The second commit. Come on, everybody. Lunch was good, wasn't it? But we know winter is coming. That's right. We're going to make that second commit. And that's usually pretty good. It's not too bad. Sometimes we're feeling pretty good about ourselves. That third commit, maybe we had to make a quick change. I've seen messages like, fixed it, followed up by, no, really fixed it. Followed up by, no, seriously, this time I fixed it, I promise. And what do? We push it around. That big ball of mud, it just keeps growing on us and growing on us. And despite our best intentions, it gets out of hand. But how did we get here? Did anybody wake up today and say, I'm going to write bad code? No. We got here from things like pressures from outside engineering. How many people have to work with product teams and sales teams? What do you guys do all day? You guys write code in isolation, right? You just get to sit around and write this pretty code. But no, I have a business team that says, hey, we have this feature that we promised to this customer last week, and we need it implemented last week. Can you get it in there today? Things like that, oversell. But we also have things like developer turnover. I mean, you weren't the first employee necessarily. I mean, I guess you could be, but you weren't the first employee at your company. So chances are you had other developers working on it. Some of them wrote good documentation. Most of them did not. So we're left with this ball of mud that, over time, gets bigger and bigger and bigger. And it becomes unmanageable. And then product comes to you and says, hey, I need this new feature. And what happens? It'll be 6 months. So I had this lovely tweet not too long ago about abstractions. And Sebastian called me out on it. Just in case for those that might not be able to read, I know that ended up being a little small. Basically, I had said that sometimes we abstract too fast. And we are so focused on the code abstraction that we forget that that's not really what abstraction is. If we thought of it more as isolation, and isolating business logic and understanding and business knowledge, then we could build better abstractions. Of course, Sebastian let me know that basically I was talking about overcomplicated engineering and that really what I was describing was abstraction. But herein lies the problem, is some of these things that we've been talking about, although they go back years and years and years before most of us were developers, they get distorted over time. My favorite is dry. How many people dry up their code? Nobody dries up their code? Well, what are y'all doing in here then? You guys know this stuff. The truth is, and in perfect timing, as always happens, the 20th release of the Pragmatic Programmer is coming out. This was written by Dave Thomas and Andy Hunt 20 years ago. And they've actually gone back and added this addendum. You should definitely check this book out. Even if you read it 20 years ago, they're updating it. They're actually including Elixir code in it as well because of some of these topics. Designed by contract and things like that, they're all covered. But they've come right out and say, this has gotten distorted. And I know I've had conversations, and I'm sure you've had conversations with people that they say, oh, well, we just need to extract this code out. And they use terms like, well, if we create this function over here, we can then reuse it all over the place. But what are you extracting? The knowledge is what you should be extracting. The code is a very trivial piece of what you're actually abstracting. What you should be doing is you should be isolating that business logic into a nice encapsulated, yes, I'm going to borrow from object-oriented methodologies, encapsulating that business logic so that it's in one place and it can be then reused across applications or across even a single application. And the thing is, and Leonard, thank you for adding this, it's a single record of truth within your system. It is a single piece of knowledge that you can then take and then you can reuse that knowledge. But if all you're focused on is the code, that knowledge gets distorted. Now, I'm going to tell you a little story. So Phoenix, if you're familiar with the Phoenix web framework, I don't know if anybody's ever heard of that. I worked with Chris a long time ago on it in the very early days, and one of the things that we had done was we had implemented a library called Inflex. If you're an Elixir user, chances are you're probably using it and you don't even know it. What it was back in the days of Rails, what they would do is they would take controller names and they would pluralize. So like all your models would be pluralized into controller names. Well, sure, let's do that. So wrote a library that handled it. You know why? Because Rails had a library that handled it. Active support. There's a whole part on inflections. Well, what happened was I created this library, we started using it, but then I started thinking, well, why don't I add, we have pluralization and singularization. What about parameterization? What about all the other things that active support does as far as the inflection library goes? So the library started growing and growing, and people started using it for different things. Well, then Jose came along. I was like, why are we using that library? We only need two functions. Two very simple functions at that, singularization and pluralization. So they took the code out and put it in Phoenix. But then it came up, why are we pluralizing controller? Because Rails did it? Why does that mean we have to do it? So the code has since been extracted from Phoenix. I think that was a good call. And in true justice, now I'm forced to maintain a library that I don't use. Another good, quick little story, in fact, 10 lines of code quick. Anybody remember LeftPad? The day the internet broke, or at least all your Node applications. Here's LeftPad. It's roughly 10 lines of code. Node used it. Babel used it. Pretty much most NPM packages probably used it at some point, mostly because NPM packages are generally some sort of hodgepodge of all sorts of other libraries all bundled together, and they're all dependent on one another. And so what happened is the developer had another library that had nothing to do with LeftPad, actually had several libraries on NPM, and a corporation came in and said, you're using our name, you have to pull it. NPM pulled that library. So the developer said, if you pull that library, I'm pulling all my libraries. When he pulled that one, the internet broke. Now, obviously, I'm going to go back to the idea that if we extract our code out and we're concerned on the code and we use libraries, actually one of the things about Ruby that kind of got me when I first got into Ruby was the first thing that they tell you is, just use a gem for it, right? It's already been built, use a gem. Well, what's in all those gems? This is a basic Rails application. I mean, like Rails new basic Rails application. These are all the dependencies. I can't even read them on the screen, but I'm assuming that you don't know what some of these do, or if they're even needed. Maybe. So I come back to dry, and I say that dry is about the duplication, or dry is about not duplicating knowledge. Dry is not about your code. Now, I'm going to take some time here. I'm going to explain a little bit how to implement this. What am I talking about? Because the beautiful thing about Erlang and Elixir is we can have these tools at our hands. It is very easy. The languages give us everything that we need to separate that knowledge from our implementations. Give me just 1 second here. Let's see. All right, I'm going to switch over to mirroring. And we're going to look at some code. Of course, I was making sure all this looked great and forgot to put us right back here. Now, one of the writers at Prague came up with this book called Exercises for Programmers. Have you ever heard of this book? Okay, I highly suggest you check it out, especially if you're someone that's mentoring somebody learning the language. It's a great resource. What it is it's a series of exercises that are, most of them are pretty short, but there's some more longer ones. This being one of them, short URL. And one of the things that we've done at Weedmaps is we started doing our lunch and learns. And as part of our lunch and learns, we realized that we have a range of developers. Some of them are experienced Elixir developers and senior developers, and then some of them are junior developers, and some of them are Rubyists that we have on the team that are learning Elixir for the first time. And so what we did was we come up with this idea of doing exercises, to where these exercises, we can take kind of extractions from the book, and then we can design constraints that we want to apply to teach certain concepts from Erlang or Elixir. This particular one is called short URL. Most people are familiar with this concept where you put a long URL and it spits out a short URL. Now, what we wanted to do is we wanted to make people change the way that they were thinking a bit. And so one of the things is, one of the constraints, you can't use Phoenix. So you had to pick some other way of building a web page that you could submit to. You can't store data in a database. You have to store it in memory. Now that leaves you a lot of options. Obviously you can use agent, gen server, ets, whatever you want to do, but you just couldn't use an actual database. So those are the basics of this project. Now, I chose to use racks. If you're not familiar with racks, Peter Saxton will be doing his talk on racks, I think this afternoon at 4. I highly suggest you all take a look at that. Racks is really fun to use. In fact, I'm going to show you a little bit of the code. Instead of having to do a whole Phoenix application, let's see. That's one. It's a single dependency on the library. This is my racks file. It's my module that it handles a request. Basically, give it a message that you're gonna receive, and then you respond. It's very convenient if you're just wanting to throw something together real quick. And here I'll kind of. This is the page that comes out. I know what you're all thinking. Man, he's got good CSS chops. But believe it or not, I don't. So we got this, and boom, there's the Rack docs in our nice short URL. So part of the thing is we have to receive a long URL, we have to save the URL in memory, and then we have to be able to give a shorter URL that can be then you can go find. So we have the lookup and we have a commit. Now our commit has logic, because if somebody creates a new short URL and it's already in memory, why bother creating another one? That would get confusing. So we want to make sure that we don't duplicate URLs in there. So this is our logic, our business logic that we're trying to conform to. Now, here's our gen server. Pretty simple. We're going to do a spec, which I'll get into a little bit more in a few minutes. I mean, that's part of our way of doing design by contract. But we have our commit and our lookup. This is all kind of standard. The functionality, our business logic, is all tied up in this handle call. It's our commit message. Believe it or not, I intentionally wrote it this way. So we have our ability to create a key for that record, which is here trapped in our handle call. We also have our updated state that we're doing. As if the URL is there, then we just return it, return the shortened one. If it's not there, we add it into our list. If there's an error, we return an invalid state. If it doesn't exist, and basically if the state isn't a list. We have our lookup, which also has business logic buried in it. Our ability to actually look the URL up. And even better, we've got private methods, or private functions, buried in our gen server. All our business logic is wrapped up in this module. Well, the requirements have changed. I don't want you to use a gen server anymore. I want you to use an agent. I know that seems trivial, but it could happen. So now I need to have this knowledge somewhere else, because I can't reach into here. I need to use an agent. I guess I could duplicate the code over there, but now I have business logic duplicated in 2 places, right? And what's even worse is I don't even have a contract to know that I'm guaranteed that I get the same information back, and I don't handle error cases. So what can I do? Well, if I extract this, and I pull out the, first I'm going to pull out the generate key, because that's one thing that everything's going to need, right, to be able to generate a key. That's central business logic to make sure I'm storing it the same way every time. So I can pull that code out. I can use pattern matching here on the handle commit, to where I can have a nice, clean, easy to read way of saying handle commit. I'm going to take whatever state, which that state should be a list. If it's not a list, then it's not right. Send an error back. I can look exactly the functionality that I had in that gen server. I have now extracted that business logic out and put it in a separate module. My lookup is the same. I can extract that out and pull it in. So now, let's see. Let's go back here. The first thing we can do, let's go ahead and import. Live coding is so much fun, isn't it? Let's store it, that's why. Okay, we're going to import the helper. Obviously, we can whittle that down and just import the functions that we want. So down here, how does that change things for us? Well, if we do that, let's see, our handle call now cleans up quite a bit, doesn't it? Because now we don't have this business logic in here. We can delete that. We know we're going to need to return this. So if we take this out, what's our contract say? Okay. We have a contract that's telling us handle commit. Handle commit is going to take a list. It's going to take a string and two strings, and then it's going to return back a tuple with the string and the list. So we can, just for, I'm going to write this actually. Key. State. I should say new state, because, you know. And then commit, which it takes the state, and then key, or well, at this point I don't need to. I think I actually pulled one too many. Let's do this. Okay. Which takes. I'm telling you, I highly suggest you always do live coding, especially when you've rehearsed it a bunch, so that way you can make sure that you got it right and didn't accidentally delete the wrong thing. So that we got this. And so we know that our state should be this. We can now take this. Yeah, that's right. Believe it or not, I don't get paid by the keystroke. All right, so there's our handle commit. Now let's verify that the other thing. No. I did not. We don't need this stuff anymore. And I think, pretty sure we can get rid of this, but we'll just double check that real quick. There we go. Still work. Okay, well that one's done. Now if we go over here and do, so we can definitely get rid of these. And this one ends up just being key. Yeah, it probably would be good to pass the state in there, right? I'm telling you, I would highly recommend live coding. If you can do it, it's just awesome. Handle lookup. Oh, thank you. Good catch. So funny story about a new Mac. How many people have new Macs? Yeah. How many people have random keys that stick? Yeah, S being one of them. What's fun is when your password has an S in it. But don't worry, my password's not just S, so fooled you. All right, go here, let's create it. Boom, and there. Yay. All right, so we've successfully extracted out that business logic. Now what we can do is we can come over to our agent module. Oh, wow. You don't have to watch me type out a whole agent. And now we have calls like function, or like the commit and the lookup, that now just go and reuse that code that we have already created in that separate module. If at any point in time we come back and say, hey, we want to adjust the way that business logic works, we go to that module. If we want to replace that module altogether, we can replace that module altogether by just changing line 8 to bring in whatever other module we want. That's where our import is. As long as we maintain those contracts. The contract for handle commit and the contract for handle lookup. Whatever happens on either side is fine. Now, the thing about contracts is, as of right now, if you look at commit, this contract is actually bundled right here in this gen server. So what we can do is we can utilize behaviors and extract that out. So now our contract is in one single place that we can now reuse, just like an interface in most other languages. It's almost the whole, the animal. I don't know how you remember learning object-oriented, where is a dog an animal or is a cat an animal? Well, kind of the same thing with an interface. So we know that our interface, our contract for anytime we want to write a module that can commit and look up data, we have our contract right here. We just have to implement that our interface. Now, back to our short URL. We can come into here and create this. Is it easier to see with or without the highlighting? Where we actually pull from our environment and we say, based on our configuration, which are you using? Are you using the agent or are you using the gen server? And if I've done this correctly, knock on wood, and spell agent. Let's see. Are you nervous? I am. If this doesn't work, like the last 15 minutes or 20 minutes is blown, right? Oh. Oh. So we successfully swapped out one implementation for the other. We can go back into that module. We can delete that business logic. It's all centralized in one place. And that's the trick to these balls of mud, is if you centralize things in small areas of your application, if you divide that ball of mud up into several smaller balls of mud, it gives you more control. As business requirements change, you can go in and you can adjust that one. You can delete it altogether. There was actually a talk that kind of gave, I've been kind of mulling over for a few years now, by Greg Young, called The Art of Destroying Software. And he specifically called out Erlang as being one of the things that he got into, that he realized that you should be able to rewrite code in a day. A new feature, getting rid of an old feature, you should be able to go in there and scrap code and rewrite it. Now, obviously, if you have a very complex problem, you might be scrapping lots of little balls of mud. But in theory, if I said, I want to change this one thing, you should be able to go directly to one piece, scrap that bit of code, and rewrite that business logic. You shouldn't have to go through 10 modules and change functions all along the way, right? How many people have had to traverse through code after code after code to see where the actual business logic is? Oh, come on. Yeah, I know. It's okay. We're all friends here. So, we've covered some of the techniques. Oh, I guess it would help if I went back to... I know y'all all want to see my speaker notes, but... There we go. So one of the concepts that really helps with this is design by contract. Everybody's familiar with it. If you're not, I highly suggest you reading up on it. Because the thing about design by contract is, it's where you define your data structures. And when I say data structures, I'm not talking about your customer data structure. I'm talking about the messages that you're passing in and out. You're calling functions. Well, that function is supposed to receive a message. That message might be a tuple. That tuple is the data structure that is supposed to receive. It also helps to separate behaviors from state. You can have, even when you create processes in memory, you should have state stored somewhere else and how you're interacting and how you're working with that state in another process, if you're using processes, or another module. And it's okay to use modules just to define how to act on that state. So maybe you're using a gen server to store the state of some type of data structure, and then you're having, based on some sort of reaction in your system, you grab that state and send it through a series of functions through a pipeline to transform that data. And use specs. Everybody in here uses specs, right? Yeah. That's the easiest way to define your contracts. But remember, contracts aren't just about what you receive and what you get. They're also about how you can fail. You should always add the error handling to your contract so that the person utilizing that contract, or the part of your application that's utilizing that contract, understands what to expect when things go wrong. Because inevitably things will go wrong. But what it all boils down to really is focus on the data transformation. Focus on the conversation from data moving from here to here. Make sure those contracts are set up all along the way. Hey, we can do it. We can get on top of that ball of mud, right? We own it, embrace it. Love our balls of mud. Like the poor little dung beetle that's been pushing that thing around all day finally gets on top of it and he's got it under control. I do want to add one thing to this too, is some of these concepts have been around from OO side of things for quite some time, and some of them transfer over. But I hear a lot on the internet about functional programming versus object-oriented programming and how this one's better than that one. But the truth is, is you can borrow concepts from both and make better applications. And take the things that we've learned in the past and bring them to our new languages that we're learning or new applications that we're building. We always pull our experiences. I like the thought of, when you go on a trip, you can take your baggage, but you don't need to pull out every outfit. Some references for this talk: the Big Ball of Mud paper, if you haven't read it, maybe go read it, it's cool. Definitely check out the talk, The Art of Destroying Software by Greg Young. I highly recommend 2 books, The Updated Pragmatic Programmer by Dave Thomas and Andy Hunt. They've gone through and they've kind of cleaned up some of the things. The thing about saying something 20 years ago is everybody gets a hold of it and changes it to kind of suit their needs, and then it becomes dogmatic after a period of time. They've actually come back and said, hey, look, kind of like the quote on Dry, it's like, look, it got a little confusing. We're going to try to fix this up here. Let's focus on what's really important. And also exercises for programmers. Not just for yourself, but if you're in a role as a mentor, it's great. It's handy little projects that are kind of templated for you, so you could go through and you can put constraints on them based on what you're trying to teach. I know a lot of people come to me about mentoring and how to mentor junior, mids, and sometimes even senior developers. It's nice. So one of the things that I kind of got in the habit of for a while, and since gotten away from, but I want to get back to it, is before I really start my day coding, I'll do a little exercise. A little practice something. It doesn't have to be anything that's going to take hours, maybe 15 minutes, just to warm up the brain. So I highly recommend those references, those resources, and any questions? Questions? Oh. Sorry, I'm not giving everybody the scowl, by the way.
Thanks for a great talk. I think a really important point in what you just did and showed is that by extracting the logic, you took what was a big ball of mud and gave it a language and defined what it means, and then it becomes like its own thing and not a big ball of mud anymore. And I think that's one of the key points to building maintainable applications, because now you have a language that you can use to reason about what's going on rather than just having a series of low-level data transformations.
Yeah, and I think that does kind of say something about the way we talk and reason about things. Words are very important. It goes back to the abstraction versus isolation. Sure, when I talk about it, it's the same thing. But does it mean the same thing in context? And when we think about isolation versus abstraction, we're saying, this is code I'm isolating. This is business logic I'm isolating. And then yes, you do. You start forming languages around that. Especially specs are great for that. You're describing something. You're basically providing a definition of how you're wanting to talk. I think that's great. Thank you.
Okay. Have we got any more questions? All right. That's
Perfect.
it. Thank you, Johnny.
Thank you. And by the way, thank you to Erlang Solutions. This is probably, I think, my 3rd or 4th time here in Stockholm. It's an awesome conference. I hope to see you all again next year. Thank you.